Welcome back. Today we are looking at std function. It can hold lambdas, function pointers, functors, all in one variable, but abstraction should be zero cost. Is std function zero cost? Spoiler alert, no. Today we will look at the assembly and see exactly where your CPU cycles go when you erase a type. First, let's establish a baseline. When you call a function directly or use a lambda without type erasure, the compiler knows exactly where the code lives. That will be our example function. Now the main. Now, if we check the assembly, in this example, I'm just calling the lambda. And here we can see a direct call to its function operator. But here's the main thing. The compiler knows that lambda, knows where it is and how to call it. Same thing with we use the function here. We can see it knows how to call it directly. And if we optimize it, for example, with auto, now watch what happens. It's all gone. It literally knows that these two numbers summed up equals 3 and it just inlines it here. And that's the point. This is inlining. Cost is literally 0. Now let's add another layer, a function pointer. Now, if we check the main function, we can see that there is a function call, but at this time, we don't really know where fn is pointing to at runtime. The compiler can no longer inline this easily. We introduced an indirection call. CPU has to look at the address stored and jump there. It's still fast, but breaks the compiler's ability to see through the code. I believe that if we raise the optimization level, it will still be very similar, but actually not really. We load the address here, and then we have a jump instruction to whatever that pointer is pointing to. We have introduced an indirection, and as you can see, the compiler, it can optimize it. It can optimize it very well, but still not like the example with just calling it directly. Next thing is the std function. This is where things can get heavy because std function uses type erasure. So imagine a box, you can put a tiny lambda in it, or you can put a massive object with array of integers. The outside of the box always looks the same. We have std function. Now under the hood, std function is usually a struct that contains a function pointer there called the invoker. That's a helper function that knows how to call your specific type. It also would have a storage buffer, a small internal array, usually between 16 and 32 bytes. Now, when you call this func object here, let's assign it our add function. Now, when you call func, what has to happen? It needs to load the address of the invoker, then load the address of the data, the lambda or object or function, perform an indirect call to the invoker, and then the invoker performs another call or execution of the actual code. And we can see in the assembly, these instructions, they prepare the location of the add function in memory. Then we call the std function constructor. And we can see here that that's how we call the function. It basically finds the function operator and calls that. You might wonder, does std function use the heap or does it always use the heap? The answer is if you're too big. Most implementations use small object optimization. If your lambda or function is small, it captures small variables like 1 or 2 integers. It stays inside the std function object's internal buffer. So no heap allocation required. But if we exceed that internal buffer, we will actually, the std function logic, it will have to allocate memory to the heap in order to allocate the size of the object. In this example here that we have with the add function, and actually I have tried it with, for example, lambda that captures big array or it is using something big inside it, we won't see really a call to new just because it's often hidden inside the standard libraries type Erasure machinery, but the performance hit is real. When the object is small, it lives right there on the stack, but when it's big, std function switches gears. The occasion requires memory from the heap, and then std function object now just holds a pointer to that heap memory. Every call to the std function makes the CPU jump to that heap location, and that's the performance hit. We can introduce, for example, cache miss risk. Instead of the data being right there in the local stack memory, the CPU has to fetch it from the heap. In a tight loop, that extra hop can be the difference between high performance code and a bottleneck. Let me just show that std function machinery. I will be using GCC, and this machine is running Ubuntu. So on another GCC version or Quank, it might be different, but for this example, we'll use GCC. Now I have here, these by the way are the episodes. I'm slowly adding the examples and pushing them into GitHub, but just for the example, I will be so if we go here, we can see, so that's the class function. Now obviously the standard is difficult to read, so yeah. Now I need to find the constructor, and we can see the different constructors. Here is like a default constructor. Here is the copy constructor, right? Yeah, copy constructor. Now if we do, for example, the example that we have in Godbolt, and we do this, now that add is, this should be, this is it will use this constructor here. Yes, it's not move constructor. Here's it, build a function that targets a copy of the incoming function object. And we have our function object here. Now in the standard, if we open CPP reference, we can see that as well, it has to be copy constructible and constructible in general. So, and here is the init functor, and if we open this, we can see this. So this is our functor. No. So yeah, this is our function, and we can check the create. Now there is to create implementations, and we can see that the first one is using in place new, and the second one is just calling new on the functor. The functor is the object that holds the callable that we have passed. So yeah, that's the idea. And as we saw, it either for this GCC version, it will either use in place new or just call new. That's what I wanted to show. Now, when to use what is the next question. So should you like delete std function from your code bases? The answer is no. You just need to know when to use it. And yeah, use templates if you can. If your function can be a template, the compiler keeps the concrete type and can inline it. Use std function only when you need a container of different things like vector of callbacks, or when you need to hide dependencies in a header file. And watch your captures. As we saw in the standard, it might trigger a heap allocation, so keep that in mind. And abstraction is powerful, but it's never free. Next time you reach for std function, ask yourself, am I calling this once a second or a million times a second? And that will be for today. Thank you all for watching, and I'll see you in the next video. Bye bye.